Yes, Jano.
Yes.
What's your next question? Further to our last video.
Yes, sir. So, as a fresh engineer, what are the basic NDT techniques which he should know?
See, the common ones one should know, which more or less people get into, are ultrasonic, radiography, magnetic, and penetrant. Now, the choice is dictated by what you are seeking, what defects. If it is surface defects, the choice lies between magnetic and penetrant. Now, how do you decide which one to use? That depends on your material. If it is magnetic, or what we say ferromagnetic, if it is attracted by magnetism, then we go for magnetic particle testing. A magnetic particle testing has an advantage. It can detect not only surface but also near surface defects, and especially when the defect is filled with contaminants or grease or anything. So it doesn't require extensive amount of cleaning as compared to penetrant. Penetrant you need thorough cleaning, because if the cleaning is not good, penetrant will not go inside because it has to go inside by capillary action. So penetrant and magnetic both are good for surface defect. Penetrant has relatively good sensitivity, higher sensitivity, more cheaper, easier to learn because of its simplicity, and extreme portability for penetrant, because penetrant you can, all you have to do is carry the cans and the cleaning cloth, because especially in the solvent removable method you use the non-aqueous developer, so no need of electric power. Whereas magnet, you do need power, whether you use electromagnetic yoke or rod or even the beta horizontal machine, which is of course in the workshop. So electricity is needed. Both are all position. Advantage of penetrant or magnetic again is penetrant can be used on any material, even non-metals. So you can use it on metals, non-metals, as long as they are smooth and non-porous. And of course, the cleaning requirements are more stringent in penetrant, and you have to be careful when you use penetrant on stainless steel, because there is likelihood of stress corrosion cracking, especially because of the chlorides. So only the you have to see the penetrant is compatible with the material when you use with stainless steel and nickel, because stress corrosion cracking is something. So most manufacturer will limit the chloride percentage less than 1%, which is a requirement. Magnetic, there is no such issue. But magnetic particle has other disadvantages. As I said, you can use it only on ferromagnetic materials. You cannot use it on non-magnetic materials. And magnetic particle testing, apart from portability, advantage is it is faster. But again, you cannot use it on stainless steel. When you use the word stainless steel, you cannot use it on typically austenitic stainless steel, which is a 300 series. So you can use it on ferritic stainless steel or martensitic stainless steel. You can test both. So magnetic particle testing, you have to be selective of the material. There are few materials that can be used, like cobalt, nickel, which are magnetic, and of course iron and its alloys. So these are the magnetic ones, and you can do it in all positions, especially for root pass. Use magnetic particle testing when you initially qualify the welders. It is relatively fast. So your dry method, your wet method, depending on the type of examination, the sensitivity that is desired. For fine cracks, wet is good, and wet is in all position. Dry you cannot use in vertical position because the powder can fall. So it is possible only in the down end position. So whether to choose magnetic or penetrant again will depend on the material, the surface finish, and the type of defect, and the cleanliness. So all these things count. As I said to you, to summarize, if the part is less clean and it is magnetic, the choice of course will be magnetic. And magnetic is an advantage. You can also detect near surface or subsurface defect, which you cannot do in penetrant testing. Penetrant is highly sensitive, highly portable, but a limitation is good amount of cleaning is required. So without proper cleaning, penetrant will not be effective. So the choice is dictated by the material and the type of defects you are seeking. Next comes the volumetric. Now, volumetric has more advantage that it can scan the entire volume. So you can actually know precisely the defects that are inside, especially with ultrasonics. You can size them, you can locate them precisely. Also with the radiography, you can know, but the depth information in radiography is not very good. So relative to compared to radiography, ultrasonic has advantage as far as the accuracy of depth information is there, and also the limitation on depth. So ultrasonic can penetrate more depth, much higher than radiography. So both are volumetric, but then radiography is relatively expensive, but and it is hazardous also. So again, you have to decide what thickness you are examining, what material, and what are the defects you are seeking. So radiography, as I said, use the source, which is a radioactive source, which is ionizing, can cause damage to your tissue. So there is a lot of safety requirement that is needed. Most of the isotopes that you use are iridium 192 or cobalt 60, depending on the thickness. Iridium 192 typically is up to 3 inches, or we go for cesium 137, one having very long half life up to 30 years. Half life is something, the intensity of the source will fall with time. So you know to double the exposure after each half life. So this is a problem, especially with iridium, because once it decays means it loses the strength. You have to again export it and get a new source. So likewise, cesium has long half life, up to 3.5 inches you can use. Or for thick material like 6 to 8 inches, you can go for cobalt. So cobalt is more dangerous because it penetrates more, it has greater energy, obviously more ionizing power, and it's used even in cancer, in chemotherapy. So cobalt is very, very restricted, and you have to have a license to use these sources. You cannot just get source off the shelf, because you have to have a license to use, and you have to train these people personal in radioactive material. So regulatory bodies will train you how to carry out the work safely. Okay, and radiography main disadvantage is the depth information is not there. Because although it will penetrate, you do not know precisely the depth. We do have some techniques that are available where depth is possible, like parallax method. We can use or tomography, CT scan. So still, it is not very accurate. We also have got a stereo radiography we use two radiographs to get the depth perception, but not very quantitative terms, but rather qualitatively. And penetration is relatively less in radiography. I said with cobalt you can penetrate up to 5 to 6 to 8 inches, that's maximum. But you have linear accelerators available that can penetrate up to 26 inches. You can go for linear accelerator, or you can betatron that will penetrate up to 12 inches. So that is those high energy sources are available. Now here the distinction is, I told about the radioactive isotope. You can also have an X-ray machine like this linear accelerator, where this electromagnetic waves are generated electrically. So you can shut it down, and that's safe, because once the job is over, I just shut off, I turn the current off and finish, and then it's safe. You can even sleep next to your X-ray machine. There is no any danger. But gamma ray is continuously giving the radiation, so it needs shielding. You have to store it in a source pit under strict this thing condition. You must have a thick wall and monitor how much radiation is coming out every time. And the persons have to wear this badge monitoring. They have to monitor monthly how much radiation they receive in the course of their work, plus their electronic dosimeter, everything. So this is expensive. Not only the setup cost of the facility, the capital cost is extremely high to get source, camera, all these are expensive. And monitoring, you have to find a remote location. You cannot set up radiography facility in a populated area. So these are all the disadvantages. But only disadvantage I see in radiography is there is a permanent record. And that's the reason it has won the trust of clients. Client always used to prefer radiography before, because they see the films themselves. They think, right, what is present in the job, I'm able to see myself. But that is not true, because ultrasonic does the most capability as far as the accuracy of characterizing is concerned. The depth, it can penetrate meters, even 2 meters, 3 meters. So when the thickness is high, ultrasonic is very accurate. But ultrasonic has limitations, especially for very low thickness, 3 mm, 2 mm. It's not, you will get non-relevant indications. So you have to go for radiography. So radiography complements ultrasonics as far as thickness is concerned. So low thickness, I would go for radiography. High thickness, ultrasonics is the best. And ultrasonic earlier issue was there was no permanent record. That was the only concern, but now you do have permanent record because you have all computerized scans. You can store the data. You can have an encoded scan like in phased array and TOF, and then you can do the post analysis. So everything is available as stored this thing permanent record. You can print it out. So today ultrasonic is changed because you have the advanced version phased array and TOF. And ultrasonic is accurate. One side access is there. For radiography, you need two side access. You have to have film put on the other side. So if the plant is running, your equipment is in operation, you cannot use radiography. Of course, when people are around. But ultrasonic you can safely use, even we are surrounded with people, because this is mechanical waves, sound waves, they are not harmful. Also, one side access will serve very well. So you can take the readings, especially the thickening reading, laminations. And one advantage of ultrasonic is it is more sensitive to planar defects. Planar defects are the ones which are most damaging because like lack of fusion, lack of penetration, cracks. This can propagate into you big failures. These are the ones well picked up by ultrasonics, but not by radiography. Radiography will often miss lamination, sometimes lack of fusion, even sometimes crack, unless the orientation is favorable. So depends on the orientation of the beam. But here you have a choice, you can choose different angles. Or in phased array, with single probe have multiple angles. So the characterization is so perfect and so accurate. Also the distance that you measure is also absolutely accurate in ultrasonics. I can precisely measure the depth, which no other NDT method does. But ultrasonic, I can know the depth or the distance once I know the velocity accurately. And of course, I can size it. From the echo, I can compare it with another artificial flat bottom hole, any other thing. I can compare little bit qualitatively, but the distance information is absolute. It's very, very accurate. So ultrasonic is much superior to radiography if carried out properly with proper specification, and the technicians are well trained. Because radiography, well, the radiographer takes the radiograph and then anyone can view it. So radiographer need not be the one who will view the radiograph. Radiographs will be viewed by any person, third party inspector once it is sent, because you take the exposure on the film, depending on the source strength and SFD, you take the exposure, you process it, which we call developing, and the film gets ready. And then you can view on the viewer, you see the requirements, whether the sensitivity is okay, and then you look for the defects. So sensitivity means the quality requirement of the radiograph, which you have to see first. Okay, so this I tell first. So sensitivity part is first, and then you should inspect or the interpret for the defect. So defect is the later part. So if its sensitivity is not acceptable, they can give or ask for reshoot. So like backscatter, you have to check for the letter B. If the lighter image is there, reshoot. Or if there is any letter in the area of interest, then reshoot, because it might mask some cracks like heat affected zone cracks. So the penetrometer, right penetrometer should be used based on typically nominal single wall thickness. That's whatever reinforcement permitted by the code. So whether it is used, preferably use source side, but when it is not possible, you have to use film side. Like depends on double wall, double image, you have to use source side only. So these are all the things which you must first verify when the radiograph is ready. Don't look at the defects right away. First you see whether or not the quality is acceptable. You need the required density 2 to 4 for gamma or 1.2 for X-ray. Or if it is a composite multi-film, then minimum 1.3 density on each film. Sometimes you put more number of films, I told in my last video, to cover more latitude. If I have more thickness variation, I can cover number of high contrast films, which is called multi-film technique. And then each film must have density 1.3. So you measure the densitometry is there, you measure the density, you check for the penetrometer wire, you make sure there are no artifacts. Artifacts are those which are like processing marks, your finger marks or whatever. So that part also you have to make sure it is not present, and then you find the defects. You measure it like slag. Mostly these are the dark higher density areas defect, because they have less density, they will absorb less radiation, so more radiation reaches the film, except tungsten inclusions, which you find in GTAW, gas tunnel welding. So JIT will give tungsten inclusions, which will appear extremely white in the radiogram, because tungsten has high atomic number, so it will appear high this thing low density in this thing. That means material is high density, but in the radiograph it will appear as low density area. So you have to interpret You have to find what is the type of defect, and then you have to evaluate it based on the applicable codes or acceptance standard, or it may be your in-house standard. Okay, so first you have to find what. So you must have knowledge about the manufacturing process. This is very important. Like if we are inspecting weld, you should know what the weld defects are. You must know in weld there is lack of penetration, lack of fusion, undercut, concavity, excess penetration, burn through. You should know. If you are inspecting casting instead, you must know the casting defect. Like you must know in casting there is cold shut, there is hot tear, so blowholes. So you must be familiar with the type of this thing, methodology, the manufacturing process. If it's forging or forging labs, forging burrs, forging flags. So don't say forging lab in welding, you cannot. Or you cannot say lack of fusion in casting. You can say cold shut. So this is important that when you do the interpretation, you have to understand the defects. And accordingly you can evaluate it because certain defects are detrimental, so they will not be acceptable as per the code, so the part will be rejected. So accordingly you have to see the defects, its length and the location. All these things are considered for accept reject. Ultrasonic definitely superior, more accurate, more easy, economical. The equipment, normal equipment, ultrasonic costs very less amount as compared to well advanced phase radiant of omniscan machines, etc. They cost more, but then it has added capability. You can size like Toft has excellent accuracy regardless of the orientation because it is based on diffracted signal. So accuracy is much higher. That's the reason why ASME section 5 is now allowed ultrasonic in live radiography because it's rather more accurate. As I said, it is more accurate for planar defects, and we are rather interested in planar defects. I'm more interested to locate the cracks until before they propagate rather than slag. The volumetrics do not cause much of a damage like slag or anything. So ultrasonic has an advantage. It is safest, no radiation hazard, cost is less. Well, the technician needs good training. His expertise is very important, which is not the case with radiography. Radiography, anyone can take the radiograph once he gets used to it. He knows what the exposure time should be based on your source time. It's like a setup you do and then take a, a radiograph and you just do the processing. We know the timings for each developing, fixing, stop button, all that, and wash, and your radiograph is ready. But viewing can be done by some expert like a third party inspector, etc. So it need not be viewed by the radiographer. So that advantage you have in radiography. So comparatively, both are volumetric, both can seek subsurface defects, but ultrasonic is a much greater capability in terms of depth. It can scan a lot higher distances up to meters, which radiography cannot. There is no hazard in ultrasonics. It's highly accurate in sizing. Regardless of the orientation, you can choose the right probe, and it is the safest. And you can use ultrasonic on even radiography on most materials. So that is a common thing. But radiography has limitation, like single side access, double side access. Etc. Ultrasonic is easy when your work is going on. You can use ultrasonic, and shear wave will offer you much higher sensitivity for welds. Most of the cracks, especially we are seeking cracks and lack of fusion. These are the most, especially root or lack of root fusion or lack of penetration. So these are the planar defects which we are looking for in ultrasonics. So magnetic, penetrant, radiography, ultrasonic. These are the basic methods an engineer must familiarize himself with. Because whenever he gets into industry, but in normal course of inspection also you'll find someone doing one of these methods. Either you take the lamination checks initially in the plates when they arrive, or you look for the defects in the welds in shear wave examination, whatever. Or thickness gauging. You can do thickness gauging is the most common. To know whether or not your thickness is correct as per the required thickness. You must know the thickness because your life of a vessel will depend on thickness. As you know, TML, thickness monitoring, is the most important thing for remaining life calculation in pressure vessels. I take a thickness today, I take a thickness after a period of time, I find a difference, divided by the period, I'll know the corrosion rate. So excellent this thing benefits you get from or advantage from ultrasonics. Quick to use, very convenient, very safe, very accurate, and relatively less expensive. Radiography, well, it's a huge setup huge capital expenditure. Regulatory bodies will step in. They will ask many things to follow because you cannot even expose the public. Forget about your people. Your people, well, you take care of. They are wearing badge and everything. It's okay. But what about public? So to make sure that you protect public first, because they are not tolerant to these radiations. For radiation worker, the dose limits are a lot higher than for general public. You know that. So regulatory body can even close your installation down anytime if they see you are violating. And if you take radiography in common place and exposing the general public. So these are the two things, contrast, like advantages and disadvantages of radiography and ultrasonics. So these four methods are primarily important initially when you learn NDT, that is magnetic, penetral, radiography, and ultrasonic. And easy to learn. Anyone can learn this in around 20 days to 1 month, and then you can learn more and more once you use these methods in the course of your work. Okay, so that is all I had to tell that these four methods one should learn, and you can utilize this in the industry or during the inspection or during or it's anywhere you find this thing that part is not destroyed, and at every stage you are assessing whether it is safe. You do it in service, like vessels periodically you carry out the ultrasonic examination, and then you assess the remaining life. So these four methods are very, very important for a fresher to know the basics. And in later lecture, I'll touch upon the advanced methods. Does that answer your question?